In this question, we have to find the set of values for k in this quadratic equation where we have two distinct roots. Now, for the set of values, it basically means we have to find an inequality, and by two distinct roots, we mean the discriminant should be greater than 0, or in other words, b square minus 4ac should be greater than 0. So if we write down our equation, which is 3kx squared plus k plus 8x plus 3 equals to 0. If we compare it with the general form of the quadratic equation, which is ax squared plus bx plus c, then we can see that we have our a, we have our b, and we have our c. We just have to apply the discriminant. So we'll have b square minus 4ac must be greater than 0, or k plus 8 whole square minus 4 into 3k into 3, which must be greater than 0. We got these values from here as we discussed earlier. So solving this further, we'll have k square plus 2 8s are 16k plus 64, 8 8 is 64, minus 4 3 the 12, 12 times 3 is 36, so this will be 36k, which will be greater than 0. So we have kx square, 16k and minus 36k will give us minus 20k plus 64 will be greater than 0. For the factors, we can have 64, we can try 4 times 16, I believe. So k square minus 4k minus 16k plus 64 equals to 0. 4 16 is 64. Yes, and adding these together will give us minus 20k. So it checks out. So we have k square, or rather we can take the k common as a common factor, and we'll have k minus 4 minus 16 into k minus 4, which is greater than 0. So the two factors that we have are k minus 4 and k minus 16 must be greater than 0. So if we solve it individually, we'll have k minus 4 must be greater than 0, or k must be greater than 4, or k minus 16 must be greater than 0, or k must be greater than 16. And we can apply the shortcut by flipping the greater than sign of the smaller value. So in this case, the smaller value is 4, so we can just flip it to have our final answer. This is just a shortcut that works for every single discriminant question, and we can obviously check it by using the graph. So if we make a graph, let's just try this up a bit. So let's make a parabola. For the x values where it cuts the x-axis, that is because we have to look at all the values above the y-axis. So if we treat this as y, if the entire equation is y, we need to look above the x-axis where y equals to 0. So basically this part of the equation above the x-axis, because this is y equals to 0, this is y equals to 0, and we have to look for part where y is greater than 0, so everything above the x-axis. So it cuts, the intersection points are basically 4 and 16. Now we want to have our k values which are greater than 16. So k values which are greater than 16, which checks out over here. And for over here, we need to look at the values which are less than 4. So for here we'll have k must be less than 4, which also checks out over here. So we have our final value, final answers, which is k is less than 4 or k is greater than 16.